Okay, so let's start with the definition of loads, the truckloads. So I already explained you how you can add the truckloads. You can go to the load patterns and let's wait for some time. Yeah, here you have, I already added as in my previous lecture, the truckloads. So let's see this modify bridge live load, and you can see here, let me change this to kilonewton per meter. So the lane 1, lane 2, lane 3, lane 4, there are 4 lanes in this bridge project, and the speed is like 3.6 meters per second, and 30 seconds is the total duration of the bridge truckload, and the analysis will be done after every 0.3 seconds. So there are around 100 or 101 steps in this whole analysis procedure. Just divide this time by this, you will get the total number of steps and add into one. So here if you see, after 15 seconds it will carry the another truck. You can if you want to keep it, you can, but if you want just 2 trucks in the forward direction and 2 trucks in the backward direction, it's your choice, it will serve the purpose. But if you want to load your bridge more, you can either you can give it with respect to time, and you can give with respect to the distance. For example, like in lane 1 and in lane 3, I mean, which are the 2 lanes in this on the same side of the median. So you can add, like after 15 or like after 10 seconds, you can add one more truck. After 10 seconds in the forward direction, and the same way you can add in lane 2 and lane 4 in the backward direction. After 10 seconds you can add a truck to add. So now lane 3, let me check it again, lane 1, 3, 2, 4, and then lane 1, here it should be, okay, 10 seconds, 10, lane 4, it should be 10 here, modify, and lane 2 and 4. So what about lane 2? Add. So now we have trucks after every 10 seconds. Okay, so we have the truckload. Now if you want to add the asphalt load on your bridge, or you can call it asphalt bearing surface, AW, it is a kind of dead load or superimposed dead load. You can add this new load pattern. If you want to add any other type of load, like there's a signboard, or there is some any object, some collaterals, some piping, or anything else other than these loads, you can add it here based upon the type of load. You can also add the pedestrian load here if you want, but in this bridge, as there are no footpaths, so I'm not going to include any kind of pedestrian load. So okay, let's move next. Okay, I already have explained my previous part that how you can apply the earthquake loads in the X and Y direction on your whole bridge structure. Okay, so next, yeah, this is the thing. I mean, this should not be self-weight multiply, because I want to apply this load as an external load. So, and this dead one, I mean, all the self-weight will go into this part of the bridge, this load pattern of the bridge, and it will have all the self-weight of the concrete, and of the concrete, of like of the slab, and of the girders, piers, cap. It will have all these types of load, but any external dead load, it should be 0 here. Okay, so let's go to next. Now we have different types of load on the bridges, and we can proceed for analysis. We already have defined different vehicle classes, different uh, like these are the vehicle classes in our vehicle types, and then the vehicle classes. Yeah, it has to, okay, it's fine. Okay, so I'll come to the um, forces, how you can see the forces, but first let me set analysis options. uh, Analyze, set load cases to run here. Yeah, here I think there are again some asphalt load combinations over there which I could not see. Anyhow, let's see. We have truckload, which is do not run, and for all other cases to run, because this truck and HL93, they are the same thing. If you are applying a truckload, uh, then you are actually considering the behavior under of the bridge under the truck. But if you are applying HL93, so this HL93 includes the truck, tandem, and the lane, and it is a full vehicle class according to the ASHTO. So this is the more preferable bridge load which we will consider. This is just for the sake of bridge behavior when a truck will move over the bridge, or when the number of trucks will move over the bridge. So so this load, either you should have this one. If you want to include this one, then you should add the lane load according to the HL93 as a separate type of live load, which we already had in HL93. So yeah, we will delete this, or that's why it is do not run at the moment. We can run, first we run do not run all, and we just run this one, and let's see the behavior. And one more thing, uh, if you run the analysis and your bridge model is in this spine shape, like I mean all the line elements you have here, so in that case your bridge analysis will be quicker, and it will be more fast compared to the other option which you will have in bridge objects, and you use the option of like area elements. I'll show you later on. So here the analysis has been done, and you can see the movement. This is the behavior at step 1. So at step 1, your bridge are just above the I mean just entered over the bridge. So let me stop this one. So what about this is step 2, and then just click here, it will move step 3, step 4, step 9, and if you go further, step 15. So at step 18 or 17, your truck is moving away now, and see, as you increase a step, the behavior will change and it will go to the next side. So this is the one way by which you can see. The other way, if you want to see the animations, you can go here, create video, and then okay, save. Okay, start from this step to the end step, show vehicles, truck. So this is how you can see the trucks are moving over your bridge. Okay, but I mean in that case, this is your bridge. If you want to have a proper view of your bridge, you can just go on this side, or you can convert here to fill objects, extrude view. Okay, stop, and display display lanes, show lanes. Okay, here because it is a spine element, the analysis has been done on the spine element, so that is why you cannot see it here. And if you want to see the lanes, you can see the lanes over here, design, display, show Show lanes, yes, show lane, all lanes, select all these lanes and show the full width. So here you can see the lanes, and if you go to the create video truck, okay, again it is going over the spine one. Well, you can see, so after 10 seconds again you see a group of another trucks had appeared, and these trucks move over the bridge, and this video has been created, and on the top side you can see the steps. This file would be saved somewhere like in the basic one, RC bridge. Here you can see the steps are changing, and for example at step 40 your trucks are at this location, and at step 50 they are somewhere in the mid and they have crossed. And then after like if you see after 10 seconds a group of another truck appear, yes, and then it moves, so which we have already defined, and these trucks are a little bit fast, so you can reduce the speed. Instead of putting like 3.6, you can put the speed like 1 meter per second. So in that case you can show the behavior of the bridge under a slow moving truck. Okay, next, so in the next part, how you can see the forces, you can go to the display and show forces and stresses, and if you go to the show bridge forces, here under the truckload you can see the forces on entire bridge section, not on the individual one. This is the shear, under these truckloads, and all these trucks are applied, and these are the values, the moment about the vertical, and then M2 is very small because there are because M2 is a kind of movement in the horizontal plane, and this M3 is a vertical movement, vertical bending movement, which we have in most of the cases. I mean, it is due to the shear V22. So this shear V22 is like this. These are the over the spans you can see a vertical drop in the shear force, which is quite obvious, and these shear values are around 500, ranging from plus 500 to minus 500. So this value is like 450. You can see the value here, the other one here. So this is how you can see the forces in the bridge and under the truck. And the other thing, yeah, deformed shape or show forces in the frames. You can see the forces in these piers. The frame elements in this case are these girder, these, I mean the transom, or these pier cap, or these piers. So for example, if I click on the moment M33, so it has some problem with the view. We should not see the deformed shape in extrude view. We should have a spine view or a line view in which we can see all these forces. So maybe there's a problem with this view, so that's why it's taking some time. Okay, let's be patient. So in the next part, what I will do, I will unfortunately it stopped working, so but it's not a big deal because we had already run the analysis and the file has been saved, so it will be back. Okay, so the next thing which I want to discuss is about the analysis after. Now we have seen the behavior, we have seen the forces on a truck, so let's go back and now we run the analysis. Run analysis under do not run and run all, and I do not run this, yeah, this case, and then run now. So yeah, let's see now the forces in the other elements, like the area elements and the frame elements, and then we will move to the design here in this, because we have like moving load case, so we can see the we can see uh, the influence line contours of different area elements, or I mean at different locations of the bridge. So once this analysis is finished, yes, so this is the deformed shape of the bridge. It's complete. Okay, so this is the deformed shape of the bridge under dead load. So yeah, and this is the deformed shape under the earthquake. If you go to start animation, there is no earthquake force on the deck, so the forces are on the frame elements, so that's why only the frames elements are moving. And if you just click on this one, now it is a Y this way. So this is the, now because we allowed the movement here, so that is why our bridge is not disturbed in this direction when the earthquake was in the X direction, but in the Y direction, yes. So the more critical forces for this bridge are the earthquake forces in the Y direction. And then this is the live load. We don't have any live load, that's why we cannot see any deformation. And then again, as fault load, we don't have any fault load. In the upcoming section, I'll show you how you can apply these loads. And yeah, this is again another fault load. So yes, so these are the loads on which you can see the deformed shape. For example, you can add dead and as fault load together and you can see the deformed shape. But if you want to see the forces, like I change the view from bridge objects to just update link object. I should go to the update link object. It will not be in the active state because I already had run the analysis, so I have to undo, which I don't want to. Okay, so let's see, in the spine mode we can see the deformed shape or the bridge forces and stresses. These are the forces on the entire section of the bridge under all these loads. Like this is the vehicle class HL93, so we don't have any. Okay, sorry, this is the model. There is no load, model load HL93. Yes, this is the HL93 in which we have all the forces. There is no axial force. This is the shear force under this vehicle class, and this is M2 and M3. Should change it to, yes, kilonewton meter. So this is the main moment M3, and this is the shear V2, which are the I mean the most interesting things for us. For this vehicle class, if you see, the shear is quite higher than around 3 times to the only truckload. So here you can see it's changing from 0 to 1500. Okay, done. Similarly, if you want to see the forces and stresses in the frames, or if you want to see the deformed shape, you can see it here. There is no AW, there is no model load, there is only HL93 and dead at the moment, and EQX and EQI. We have no live load definition at the moment. So I move next to influence line surfaces. So you can select all the lanes, and if you go click on this frame, so these are the frame elements. Like for example, the frame 18, it's blinking. If you see, this element is actually 18 element. If you say 20, so now this element is blinking. So you can see on which element you want to see the force. For example, if you click on this frame level 20, I make it okay. Here you can see the wireframes on deck or on the, okay. So this is the influence line function here. So again, influence line surfaces, joints, frames, and these are for the shear force V22. And the other thing you can see is plot over lane widths as contours. If you want to see the wireframes like this, you can check. If you don't want, then you can uncheck, and this is how you can see the force shear V22 on this frame element. This is the influence line diagram for this frame element. Okay, so because influence line is for each element of the bridge, it changes the values of shear and moment changes for each and every element for each for the traffic live load or for the truck live load. So that's why you have to identify for which element you want to see the forces or the influence line function. So next, if you want to see the the bending moment diagram under the dead load for this frame, you can also see. You can go to display, show forces and stresses, frame, and then okay, dead or HL93 33. Yes, this is how you can see. This is the bending moment diagram, and if you right click and you can move this, you can find the forces, and as you change the location, done. Okay, so and if you want to see the shear force diagram, for example, for this member, I just right click and I can see the shear V2 and M2. These are the values, but if you move this cursor, you can change. And if you see for the dead load, this is how the dead load forces will be on this member. And if you talk about this member, just right click on this one and you can see the forces on this one. So it's done. Now next, so it will be the